Hello and welcome to today's Dark Reading webinar using IP intelligence to decode VPNs, proxies, and anonymized traffic, sponsored by IPInfo and broadcast by Informatech Target. I'm Michael Krieger from Dark Reading. I'll be your moderator for today. And what does measurement-based IP intelligence actually reveal? And where do the industry's assumptions around risk fall short? Well, that's what we're going to talk about today. We'll show how active measurement can expose VPN providers misrepresenting their server locations. And we'll talk through the IP-level signals that distinguish a Fortune 500 corporate VPN from a consumer anonymizer from a rotating proxy node. Most importantly, we'll break down the detection signals available in IP data today and show how they provide the context defenders need to make graduated, informed decisions instead of binary block or allow calls. And on that note, I'm excited to introduce our speaker today. I am joined by Ben Dowling, founder and co-CEO of IPinfo. But before I hand it over to you, Ben, I just want to remind our audience of a couple of things. First of all, this webinar is interactive. At the bottom of your screen, there's some buttons you can click to learn about today's speakers, download a copy of the slides, share this webinar via social media outlets, and participate in the Q&A session that takes place at the end of our presentation. We will also have a couple of polling questions during this event. So please, when you see those polls pop up, take just a second to respond to them so we can count your opinions in what we're doing today. And also, you can use that Q&A area to let us know if you're experiencing any technical issues, and our team will do our best to assist you. Okay, let's get to it. Ben, the floor is yours.
Great, thanks, Michael. So yeah, as you know, Mike gave a great introduction there and a great overview about what we're going to be talking today. Using IP intelligence to decode VPNs, proxies, and anonymized traffic. And so I'm going to give an overview. Well, let me get to the agenda, and so here we go. So I'm going to give you an overview of IPinfo, who we are, what we do, IP data anonymization, detection signals and methodology. So we're very much focused on our anonymization data, what that is, how we put it together, what it can be used for. Then our findings, we've got a great research team that really look at the industry, the signals, the internet, and we've got some really great findings that Michael alluded to at the start on the behavior of VPN providers, some of their claims on exit nodes, and so we'll be talking about that there. Some use cases, what are example customer segments of ours and how they use this data, how they leverage it in practice. And then at the end, we've got some time for Q&A. And so I think there's a way for the audience to ask questions, and we'll go review some of those at the end and go through as many as we've got time for right at the end there. Cool, so first of all, IPinfo. Who are we? What do we do? We've been around for over 10 years now, and lots of ratings on G2 for IP data accuracy. So we create contextual data about IP addresses, right? We do that through trying to deeply understand the internet, build context, and build really high quality, high accurate products. Some sense of a scale here. So our data products cover 100% of the internet, right? IPv4 and v6 is a big focus for us. Customers can consume our data as a data download, API, within various different integrations. To give a sense of our scale, our API handles 3.3 billion API requests a day. And so we've got absolutely massive scale there. Lots of people looking up IP addresses and then acting on those. Our residential proxy data set, one of the ones I'm going to spend a bunch of time talking about today, has grown almost 8x over the past year. It's a big investment for us. I'm going to talk about what sort of trends are behind res proxies, why this is a focus for us, and we think it's important for our customers. But to give you a sense of sort of how much investment we're putting into this one and how much that's scaling, it's about 8x over the past year. Some of that's due to our efforts to improve the data and improve the coverage, and some of that is just the trends that are happening, right? And the growth of res proxies in general. I'll definitely spend some more time talking about that. And I mentioned the research teams. We've got the privacy anonymization team doing the research. We also have a academic research team, and we do a lot of work in trying to understand the internet, what's happening with it, what some of these trends are. And 4 research papers accepted to top conferences recently. So it's just a summary of some of the work we do. And so here, a decade of investment in verified IP intelligence. One of the things I'm definitely going to talk more about is our probe network. And so this is a huge area of investment for us. Is we've built out now rapidly approaching 1,500 servers around the globe. And so we have servers in 162 countries, 585 cities. And they're constantly probing the internet, right? So we call it the probe net. They are pinging, tracing, actively collecting data about the internet. And that gives us an incredible source of data so we can see what's happening on the internet. We are just over 1 millisecond from 50% of all of the ASNs on the internet. So you have incredible reach. We continue to invest in it. So you can see that the growth, that graph shows the growth of probe servers. We've been investing in this since 2021. Our goal is eventually to get to have servers on every organization on the internet in every city. It's a long-term investment for us. We think we're building this incredible data set from this and incredible insights into the internet. We recently put out a report yesterday using probe network data on the internet outages in Iran and that from the perspective of the probe network. So there's lots of really, really great data we get from that that drives a lot of our accuracy, a lot of our insights. And so accuracy, I think the key message is accuracy is really important to us, right? We care about getting great data that our customers can then action on with confidence. So this is an example of an IP address that, based on our probe network data, we're confident is in Canada, in Vancouver, and other providers put this in South Africa. And we show evidence on our IP pages about why we put it there. As our data gets better and better and better, increasingly it's different from other providers, right? Because there are all sorts of issues. I mean, IP geolocation and other data sets are hard to do right. I think there's a really common misconception that the technology is somehow limited, that IP geolocation can only be so accurate. There are all these fundamental limitations on how good it can be. And we don't believe that at all, right? And so I think we've demonstrated that with our probe network capability, with the work that we do. And so what we try and do is make it as easy as possible for our customers to understand why we put an IP address somewhere. Our data is based on evidence and observations, right? We think of geolocation as a science and not as an art, and we try and show receipts, right? So when we put an IP address in Vancouver here, and we notice that our competitors put it in South Africa, and we know it just can't be true based on the data, right? And we'll show that. And so here's an example where from 1.2 milliseconds from one of our probe servers in Vancouver, we get a ping response. Physics, the speed of light, this server has to be very close to Vancouver. That's why we put it there, and that's why we can prove that other vendors get this wrong. And so we show this IPinfo/accuracy gives a great global report on a whole bunch of example IP addresses where we see this, where we've got proof that the country is just wrong with other vendors. There's all sorts of good reasons why they put it there, right? There's lots of evidence or lots of hints that this might be an IP address in South Africa, but it's just not currently located there, and we've got evidence for that. And so, talking more about the probe network and how we leverage that, but probe network is just one of our data sources. We ingest over 10 terabytes of data a day, lots of other sources, and I'll talk more about this as it relates to VPN data. But I think one key thing here is, we collect a lot of data about the internet. We want to try and deeply understand the internet. We think about creating these data sets as really as a science based on observation and measurement, a lot of data collection, and then a lot of really smart algorithms and data processing on top of that to give us the really great data sets.
So let's get to our first polling question of the day, which is, are you currently using IP context data, such as geolocation, ASN, VPN, proxy detection in your stack? So let us know whether that's in production, whether yes, but it's only partially, or it's in testing, you're evaluating it, or it's not even on your radar. And while we wait for the attendees to respond, let me ask you, Ben, why is Whois not cutting it anymore?
Yeah, so Whois Whois can cut it in some circumstances, right? And so a lot of operators, ISPs will have hints about the location of their ranges in Whois. It can sometimes be accurate, but you're really at the mercy of that ISP providing accurate data. Mm-hmm. And in the I guess simpler times of the internet, right, where it was the internet grew out of academia, and you had all these initial organizations where there's very much a trust-based system, and there are lots of operators that are completely honest with their Whois records, and you can get great data. One of the topics we're going to talk about today is the growth of fraud and abuse and these types of things. And so now there are lots of adversaries online that like to pretend that their IP addresses are in certain locations. And so you kind of really need that verification and say, great, Whois data is one of the things that we use as a hint. Mm-hmm. But you then got to go verify, right? It's not enough to trust it and say, well, hey, someone's told me this is where an IP address, or someone's told me this. And sometimes that's accurate, and sometimes it's just a bold-faced lie. And so you kind of need that verification there on top to say, well, does this actually make sense? Is this a record that I can trust, or is it something that I actually not only want to ignore, I can then go use that as a trust signal to say this is an operator that is trying to trick me, right? Which is an interesting data point.
So kind of interesting spread here. About a third say that it's in production, about a third who are evaluating or testing, and a third who say it's not on their radar. What do you think about that?
Yeah, it's really interesting, right? So I think day to day in my job, I'm usually dealing with people that are already using our data or want to evaluate it, right? So that's the top two. I think it's great that we've got a whole bunch of people here today that are kind of considering this for the first time, or it's not on their radar at all yet. And so hopefully by the end of this webinar, we'll kind of be shifting some of those people into the other categories.
And back to you.
Cool, thank you. So yeah, I've given a bit of an overview of IPinfo, what we are, right, and talked about the probe net and talked about geolocation, right? And so at IPinfo, we create all sorts of different contextual data about the internet. Geolocation is sort of really a foundational layer, right? Where in the world is this IP address? And that can mean different things in different contexts. And it's really important how that relates to sort of our anonymization data. And so, a lot of people think about geolocation, or I guess a more traditional sort of example of geolocation is right now I'm sat in my office in Seattle on a Comcast IP, right? Comcast, just a generic popular ISP in America. And so right now my office IP is geolocated to Seattle. I am a user on that IP address in Seattle, and there's a very strong correlation between the location of that IP address and a user on the end of it, right? And there's a user on the end of that IP address, right? And so, with geolocation generally, that can sometimes be the assumption for all IP addresses, right? And that is obviously the case for many IP addresses. It is a consumer ISP, it is located in a city, and there is a user on the end of that IP address, with a very strong correlation between the location of the IP address and the location of the user. But that is not always true. And so, I'll run through some examples here. And so with VPN exit nodes, we will give you in our geolocation data a location, but it's the location of the exit node of that IP address. There is zero correlation between the location of that IP address and the location of the user. And so obviously anybody can go and download, say, ExpressVPN, could be anywhere in the world, and they could say, through the drop down that you see in ExpressVPN, say, I want to connect via Seattle. And our data will show that that is a Seattle IP address, but the user could be anywhere in the world. Anybody in the world can go and download ExpressVPN, say I want to connect through Seattle, and appear on a Seattle IP address. And so, what the location there means, where is this traffic coming from? And that those users are being tunneled through a server that is physically in Seattle, and the traffic will come from there. But the user could be anywhere. And so, geolocation there means the exit node location, and there's no correlation with the user. And so, here are some other examples, right? So for Anycast, and Anycast IP address is an IP address that doesn't tie to a specific location. So you often use for internet infrastructure, routing, things like this. And so, the internet root servers, Google's 8.8.8.8 DNS resolver, often for performance reasons, for redundancy, 8.8.8.8 does not map to a single server somewhere or even a single load balancer in a single region. Google has a whole fleet of servers all around the globe that single IP address maps to. And so there, geolocation is almost meaningless, right? And so what we'll do in those examples, we put it in the organization's registered address. So for Google, that will be Mountain View. We actually have data on where those Anycast instances are. And so if you go to our IP page on our website, we'll show you, for Google, where those servers are and how many of them there are. But single city geolocation doesn't mean much for Anycast. And then for cloud or hosting, right? It's similar to VPN. It's where's this server physically located, but there may not be a user there at all, right? It could mean that there's some automation running. It could mean that there's nothing happening at all, but it's a server range. And then for mobile connections, it's even less defined. And so generally, mobile operators will use carrier-grade NAT. They have many more devices than they have IP addresses, and so they'll pull a set of users behind a range of IP addresses. And then it's really at the discretion of the network on how they want to do that. And so, we see different things for different providers. T-Mobile, for example, in the US, will pull users in a concentrated area on a small set of IP addresses. And so they're able to say, hey, for this T-Mobile IP address, it's a user that is somewhere around Seattle, right? It may be in a suburb, maybe in a nearby town, but T-Mobile will only put users in that region through that set of IP addresses. and I'm on T-Mobile, I have a set of IPs while I'm here near my office. If I was to go on a road trip or a work trip, if I went down to San Francisco, I'd be assigned to a different pool of IP addresses. And that'd be the pool of IP addresses that T-Mobile use for users, say, near San Francisco. Other operators may do that differently. So AT&T, it's less concentrated, and so they might use the same pool of IP addresses for a whole state or even a wider region. And so for a mobile IP address, we'll tell you a city, right? The one that we think is most likely or most likely based on our data, but it doesn't necessarily have that level of precision. And so we have mobile carrier data sets where we'll tell you what operator is, and so there's caveats around that. But this is just to say that geolocation can mean different things depending on other contexts, right? And so geolocation is a really critical foundational layer, right? It's often the first thing someone wants to know about an IP address, right? Where is this coming from? What's happening? Even the meaning of that is kind of context dependent. And so there's lots of additional context that we offer that can be used with this. And to go into a concrete example, this is a VPN exit node IP address. And so I'll just run through how do we geocate this and what does this look like, and then what might you do with that. And so the picture in the background, you see all of the probes that we have as part of the probe network. And as mentioned, we're in 162 countries, 588 cities, and this is constantly growing. You can actually now, one thing we've done recently is make the probe net available to our users. And so this is a capability we've been building for a long time, is the probe network, but we've been collecting and using the data internally. So every week we'll measure the whole internet, ingest all that data, process it, and come up with geolocation and use it in other data sets. One thing we've recently added the capability for is for users to go and trigger measurements from the probe network. And so they can trigger pings, trace routes. You can go to IPinfo/probenet/live. If you're a free user, so you don't have to pay to use this, you can go in and you can just trigger measurements and you can pick a region. So you can say, I want to ping this IP address from Europe. If you're a paid customer of ours, so you don't have to pay for ProbeNet, but if you're a paid customer of ours, whether it's for a data download, for an API plan or anything else, we actually have a set of country level filters. So you can say, I want to ping this from this specific country. And this is something we're rolling out more and more functionality to over time. So if you want to go trigger some internet measurements, play with the data, we'd love to hear what you're using it for and how you do it. And we're going to build out more capabilities over time. You can see for this IP address, this is just, we're pinging it globally. We get back some results showing that there's a 29 millisecond RTT from Frankfurt there. I think it's 36 from the Netherlands. So we can already see that, just based on this is an IP address that is somewhere in Europe, right? We can see that from Chicago, it's 136 milliseconds, right? This is an IP address that is clearly much closer to Frankfurt than it is Chicago. We've got Vietnam ping time 261. This is an IP address that's somewhere in Europe, and we can see that just from results from 10 random probe servers. Internally, we ping it from the whole fleet, and we get really strong evidence that this is an IP address that's in Belgrade. But as we know, as I mentioned earlier, that means that there's a server in Belgrade that this traffic exits through, right? We actually have other data to say this is a hosting provider range, and this is a VPN range. So what we can know from that is that the user could be anywhere, right? The traffic may exit through this, but the user could be and likely is somewhere else. And so that's how our geolocation data, it's a really foundational layer, connects to anonymization data and other things, right? It's additional context that lets you know how you might want to interpret that geolocation or what it might mean. And so anonymization then is that sort of additional context there on top, right? Can be strongly associated with fraud or malicious behavior, but it's not possible to know what the user's intent might be, right? And I'll run through a bunch of examples in this section as a kind of give an overview of what our anonymization data is and how it can be used. And so here's an example for an IP address of some of the flags that we include, right? And this is actually an Apple private relay IP address. And so, I think anybody on iCloud Plus can turn this on as they go through Safari, right? They will no longer be exposing their default IP address. It will go through Apple private relay. And this is what the data might look like for those IP addresses, right? We flag it as a relay, but you can see the attributes that we do across a whole bunch of different IPs. And so I talk about the growth of our res proxy data set, right? And so a lot of that is driven by our efforts to improve our coverage and grow our data. There's also a growing trend. Obviously, the internet is ever increasingly more important, ever increasingly a platform for commerce. And with that it attracts fraudsters, abuse, and adversaries. And so online fraud is obviously a growing problem. And increasingly the data to sort of fight that becomes important. And so now I want to run through, I'll talk more about some different use cases of this data, but I want to run through the example of, say, an e-commerce site, right? And so the evolution of what fraud might look like on an e-commerce platform. And so you might imagine that someone's trying to buy something on an e-commerce site with a stolen credit card, and it could be a US credit card, but say the fraudster is in Brazil, and so without any IP context, that bad payment might go through, and the e-commerce site is out of the merchandise, and there's a fraudulent payment that is going to get charged back, and so this is really bad news for the e-commerce store, right? And so clearly there's a strong incentive to block fraud, and so the simplest thing might just be to do a country level check, right? Does the credit card country match the user's IP address country? And so, if there's some geolocation data, that's very easy to enforce. That can be done at the check level. You also might just want to do a geo restriction. So if you are an e-commerce store and you think that all of your customers are going to be in the US, maybe you say actually we only allow transactions to the US regardless of credit card. Or maybe historically you've seen a whole bunch of fraud or abuse from certain countries. And so you might just say, actually, we do very little legitimate business, say with Brazil. So let's just block all Brazilian transactions. And so, geo restrictions are a really powerful but blunt way to sort of do this first level of enforcement. Now, obviously, adversaries don't just go away, right? And so with that country level restriction, the fraudster that might be in Brazil in this example has a stolen credit card. They really want to buy some goods on the site. And so with some geo restrictions, they are blocked, but they're going to want to keep getting, they want to get around this, right? And so a VPN is a very trivial way to get around this, right? And so, for $5 a month, or there are many even free VPN offerings. This fraudster can go exit through a US IP address. And so we've talked about geolocation, right? For a VPN, that location is the exit node of that IP address. And so we're no longer talking about the user's location. The user is there. This adversary is based in Brazil. They are connecting through a US VPN exit node. And so now that initial geo-restriction check fails. The user can pass that. And so there's a US stolen credit card, there is a US IP address, right? And so that geo check fails, but we can do a VPN check, right? And so here we can say, well, we want a rule that says there has to be a credit card and country match, or we may want a rule to say let's block specific countries that the user can then, or the adversary can go bypass with a VPN. And so the next layer of defense then is a VPN check. And so a e-commerce site could say, actually, we don't allow any transactions via VPNs. It's too risky. We want to be able to go and do some location checks and filtering of users. And so if a user is connected via a VPN, then we can reject that, right? And so you could show an error to the user saying, I'm sorry, we've detected that the VPN's turned on, please disable it to proceed. Lots of different ways that the website could handle that, but they would have the signal then to say that we can see that this is happening via a VPN and we can respond accordingly. And so then that adversary that's in Brazil, they've got the VPN and now it no longer works, right? That they can no longer bypass that geo-restriction check by having a VPN because there's also a VPN check. And so the next step then, as we see that the adversaries get more sophisticated, again, the adversary isn't going to give up, right? Now, some will, right? And as there's each sort of, raising the bar in terms of sophistication, you end up with more sophisticated adversaries. And so, it's some low-level adversary that, had a stolen credit card, thought I'll give it a go from Brazil, gets blocked, they give up, right? But there is a more sophisticated adversary that gets a VPN, it gets blocked, and they give up. And then, the more sophisticated still adversary is still determined to go and commit fraud here. And so residential proxies are sort of the next layer of sophistication from adversaries to bypass this VPN check. And so I will definitely talk more about res proxies and how to handle it. But with a residential proxy, this is not a VPN exit node. This is an actual residential ISP in America. And so I'm here in my office on Comcast. And so within our data, our contextual data, without the res proxy data, this IP address looks just no different from me being in my office or someone being at home. And so it looks like a very legitimate user in the country. Now, these are harder to obtain. They are more expensive than VPNs. And so these earlier checks can eliminate a lot of the lower level fraud. But for a sophisticated, determined adversary, residential proxies are available and can bypass these checks. And that's where the residential proxy data becomes really important. And so with res proxy data, it's a more complex set of rules, and I'll get more into the false positives and false negatives. But res proxy gives you that protection around an adversary that may go to res proxies to bypass these previous two levels of rules. So yeah, stage 0 is blocked by country, stage 2 VPNs, and stage 3 residential proxies. And I think really that is the sequence, right? Each one is a higher degree of sophistication. It's the more complexity, both for users of our data, for implementing this, and for the adversary. And so, one thing we definitely recommend is, if customers are taking our data, where to begin? Well, certainly the geo-level restrictions are a good place to start, right? Layer on the VPN detection and layer on the res proxy. And we have customers coming to us, at various different stages. Some customers may jump right in and say, yes, I want to go and do the full stack of rules and sophistication straight away, which is wonderful. Beyond that, they might want to even take our data and build out their own risk models and different handlings. But for someone just getting started, that geo restriction is a great first place to start. You can layer on additional, more sophisticated rules on top of that. So talking about VPN and res proxy, that's not all that's included in our anonymous data, right? That's not all that exists in the world. We have open web proxies, we have relays, so the Apple relay, Tor exit nodes, and hosting IPs. And this is an expanding data set. We're trying to understand where fraud's occurring, where risks are occurring, what technologies there are, and always growing our privacy data and create as many signals as possible. And so this is what I mentioned on res proxies, right? They mimic real users, and so the sophistication of how to handle that depends on what you're doing. For an e-commerce store, there may be some risk of blocking legitimate customers. Now, that may be an acceptable risk, but it's something that people should go into with an understanding. A residential proxy IP address, like I say, is an actual, says Comcast or normal ISP IP address that is sometimes inadvertently being used to share traffic, sometimes knowingly. And so this can happen because there could be a hacked device. It could be a home Wi-Fi router, or even a connected fridge or oven could get hacked and be pulled in as part of a residential proxy pool. And some of the residential proxies are based on malware and hacked devices and completely illegitimate businesses that are used just for crime and adversaries. The other end of the spectrum is residential proxies that are much more legitimate. They may offer the user money or points or something in exchange for them sharing their network. And so someone might install an app and it says, hey, share your network and we'll send you some sort of bonus. And someone may be completely open to doing that. And the traffic through that residential proxy may not be fraudsters. It may not be e-commerce fraud or payments fraud. It may just be someone's wanting to scrape data or access Netflix in a different country or whatever, right? And so I think the intention of the person behind the residential proxy or the VPN is not always the same, not always malicious, or certainly different levels of risk. And then an IP address being part of a res proxy, it could be that I could be in my office here and some malware infects my machine and it started to be used as a residential proxy pool. I may be completely unaware of that, and I may want to go and transact on an e-commerce site, and it says, actually, we've seen your IP address as part of a res proxy pool. That might be something that I want to know, and I want to go and remediate that, remove the malware or something. But there is this complexity there that doesn't exist with VPNs. If I try and transact on an e-commerce site and make a payment, and it says, I'm sorry, you're connected to a VPN, please disconnect your VPN before retrying the payment. As a user, I can remediate that very easily. I can turn off my VPN and make the payment. With res proxies, if I'm actually trying to purchase something and it says, I'm sorry, your IP address is part of a residential proxy pool, as a user, I need to leave my house and go to the nearest coffee shop to connect to Wi-Fi to make the payment, or I need to submit a appeal against it. And so there's a lot more friction there, and a lot more cost to that. And so we just advise our customers to be cautious about that and understand the risks. Now, the remediation could it may be that you have to just submit for a review if you are part of a proxy pool. But there is on these IP addresses by design, there is a mix of legitimate and illegitimate usage, and so something that's really important to consider. So we include all sorts of anonymization signals. I talked about some different technologies, VPNs, relays. I talked about the example of taking just geo and then VPN and res proxy. Obviously, that journey continues, right? And so there is also this journey of, eliminating false positives, tuning it, and so just even in this e-commerce example, the rules could get more and more complicated, right? And so maybe actually, you see 90% of your fraud from one specific VPN provider. And so you could say, well, if all of our fraud over the past month has come from, say, Molvad, we want to respond to Molvad very differently from ExpressVPN, where we've seen actually we're getting a whole bunch of customer support requests from users on ExpressVPN that had a lot of friction making their payments, and they are, we're losing revenue. And so you could have a rule that says, well, if it's Molvad, we block it. If it's ExpressVPN, maybe we throw up something differently. And so we try and at IPinfo, we're always trying to create new, richer contextual data that helps users, helps our customers get more and more nuance with this. And so, beyond just the VPN data, there's lots of other data points we have. Mobile carrier, I talked about the geolocation differences between different carriers, and we'll tell you the carrier. And so all these signals can be used together to, one, get a richer understanding of the payment in the e-commerce case, or someone visiting your website, but also then gives you more tools and more controls around what you handle that, because there's more sort of data points. And then beyond the actual data points themselves, right, there's signals around, when have we last seen this, right? When have we seen this as part of a REST proxy? How fresh is it? How persistent is it? And so more and more data points that allow you to take different actions and deal with it in different ways, or just build an understanding of what's going on. Because one option for the e-commerce site is to just block it. One option is to actually let the payment through and then go investigate it, right? So before you ship out the merchandise, maybe there's a human in the loop that makes a decision on, wait, this actually passed these geo checks, this passed the VPN checks, but it was flagged as potentially REST proxy. So we can't make an automated decision, but we want to send all the data we've got, all the richness of data from IPinfo, along with a bunch of other stuff that we may have on the payment history of this account. What is it ordered before? What is the shipping address before? And send that for a manual review to someone to go and say, actually, yes, this looks legitimate, given the fuller picture of IP data, data about the user. We're going to go ship this thing to them because everything looks fine. Or no, we need to escalate it for an even deeper review, or actually, looking at the big picture, this does look fraudulent, right? And so let's block this, let's refund the transaction, and let's not send out the goods. And so there are various different ways to handle that. And the more data we provide, obviously, the easier and the more confident you can be in making that decision. Great. So going to shift from an example use case there of an e-commerce store, some of the signals we've got and how we use it, to how do we do this, right? How do we put this data together, right? And so as I've said, our data quality and accuracy is super important to us, right? We understand that there are these big decisions being made on our data, right? Zooming right into, is this payment likely to be fraudulent or not? That has real world impacts, right? On both sides, right? Are we going to block a legitimate customer that can now no longer get their goods, that can't make the payment, cause frustration, churns as a user? Or are we going to allow the fraudster through, right? Are they going to be stealing from the website, getting goods they shouldn't have got, racking up fraud charges for someone? And so getting it right really matters, right? And that's right down to, do we have the location right? Do we have the VPN data right? We understand that our customers are making really important decisions on our data, and the more accurate it is, the more they can trust that, and the more they can make the right decision. And so that goes across all of our data, the sort of the importance of quality and accuracy. But then how do we put together this anonymization data? And so a bunch of different signals go into this internally. I talked about the probe network, and as a major data source for geolocation, we actually use the probe network to collect a whole bunch of anonymization related signals. And so we do a bunch of port scanning, a bunch of understanding, a bunch of handshakes, right? We'll try and connect to IP addresses and see, is there VPN software running here, right? That's a really strong signal. Are there any ports open that are associated with VPNs? And this is one big signal we get from the probe network. One really important one as well is suspicious device activity. One of our big signals for us is device activity. Where do we see activity on this IP address through device data? Do we see this IP address has a lot of usage? Do we see this IP address with a lot of usage globally? So it's not concentrated. Does that mean that this IP address is not a strong correlation with the location of a user and actually has many users? And so that's clearly a very, very strong signal. This is a popular VPN IP address, lots of usage from lots of countries. We put in public data, so Tor and a whole bunch of open proxy data sets also contribute. And then hosting signals. We do a bunch of classification on the internet in general, but try and find what are IP ranges that we have a bunch of strong signal, hosting ranges. And lots of signals go into that again, right? What are open ports? What does the behavior look like? And the other thing that we have is we have accounts on all these providers. This will do attribution down to a specific provider. We won't just tell you it's a VPN or it's res proxy. We'll tell you that this is an express VPN IP address. And so one thing we do, we have accounts on many of these providers and we'll connect through them. And so we've observed that this is an IP address. As an Express VPN customer ourselves, say, we've gone and we've said, we'll connect via Seattle, and then we can go and see what IP address do we show up on the internet once we've got that connection. And so we get direct attribution there. And so, like I say, all of our data is based on evidence and observation, right? Now, some of it is more probabilistic, right? When we see that there's a VPN provider and we see a bunch of device data, but we haven't done we haven't tied it to a specific vendor. So we can be less confident that it may definitely be used by a specific vendor, but we know there are a bunch of signals of VPN-like usage here. And that's always based on something we've observed or something we've seen. And so we take all these different signals, we do a bunch of processing, a bunch of different things to go and produce that data set. A really important principle is that not every VPN is the same. I talked about some of the different things with res proxy, but similarly with VPNs, right? You can see two examples here. So we've got a corporate gateway here, and it's like an Apple corporate gateway, and it is a VPN, right? This is something where there is a zero correlation between the user location and the exit node. But this is probably people at work at Apple, say in this example. It is less likely to be used for fraud and abuse, right? This is probably someone that's tied on that you're at work or maybe working from home and connecting through a corporate VPN. You're probably an Apple employee, very unlikely to be committing credit card fraud. And so this could be used as a signal by the e-commerce store to actually approve the transaction, right? Or when they go and do the investigation, they might look at this and say, actually, everything kind of checks out here. And then here we got on the right-hand side, NordVPN. And so here, this is a VPN, commercial VPN provider that anybody can go sign up to and access, right? Now, by itself, it doesn't necessarily mean that there are high chances of fraud, right? You need to take the context and the full picture. It could be that someone wants to use NordVPN for privacy reasons, for all sorts of legitimate reasons. But we think back to the e-commerce provider, the context they've got is that someone is making a payment on this IP address, and there's a whole bunch of other signals, right? Where are they shipping it to? What is it they're ordering? What is the order value size, right? What transaction have they done before? This can be a really critical data point in determining is it fraud or not, but by itself, it doesn't necessarily imply that there's malicious intent, right? But it is a really important data point that helps you kind of come to that determination. And the key point here is that not every VPN is the same, right? And there's, not even every sort of anonymization is the same. And we give you the data points to kind of help you drill down and see the difference between them. And yeah, absolutely don't block everyone with a VPN, right? I think it depends very much on your use case, very much on the risks. And so we try and give you as many signals as possible to make the right decision. But then I think it's important to combine that with the other signals that you might have as a business to try and make the right decision. And so things like confidence level, percent they've seen, and a whole bunch of other data points we have that try and make this really granular and really easy. And then where can you use this, right? I've gone deep on the e-commerce example today, but clearly, this can be used. We have customers in all sorts of different segments doing all sorts of different things with our data, and we always keep finding new innovative ways that customers use our data, which is wonderful. We try and focus on creating really great fact-based data about the internet, and then our customers can go and do wonderful things with that. There's some really common use cases of anonymization data is the e-commerce example I've shared today around payments risk, fraud, and geo restrictions, VPN restrictions, and how someone might bypass that. Security use cases can be very similar. Could be used for employee login enforcement. If a work from home employee is trying to access the corporate network, you would have a similar set of rules as you might for an e-commerce store, right? So do we want to? We're a US-based company. We only expect our employees to be logging in from the US, and so you could have a geo enforcement rule there. Then you could have VPNs could be enforced, or you could have a rule to say they're not allowed VPNs. And so very similar use cases there, not just on employee enforcement, but on corporate network access, right? Is this someone that's legitimately trying to log into our network or someone that's trying to hack us? And so all sorts of really interesting stuff there. Streaming is obviously a very common one. Lots of reasons someone might want to access Netflix from different regions to either get access to different content, to get access to cheaper pricing, and streaming services and similar platforms that have to enforce regional restrictions. Obviously, gaming is a big one in the US now, where it's legal in certain states and not in others. And the same situation globally. Users may want to bypass that to appear that they're in other places, and a VPN check is a great way to sort of enforce that. Bot defense is something that we're seeing more and more of, more and more demand in res proxies from this one, as the rise of AI, and whether that's for AI labs trying to scrape data for their training, or whether it's chatbots putting in context from the web, and you can use that as a data point to understand how much bot traffic might get into my website, to my service, or to add blocks and restrictions. And so lots of really great ways to use this. So key takeaways, use these flags in models or as a rule set, not alone, right? Put in other context. I think the freshness of the data is really important. So I've not touched on too much, but I'll talk more about how much the res proxy data changes and moves around. So that's a really critical thing. And using the other signals and combining with other flags is really key. And I touched on this before, right? So what we can tell you is that it is a VPN, right? What type, additional data around it, provider signatures and evidence-based detection. What we can't tell you is what is actually going on with the user, right? What is their intent? Have they got a VPN turned on because they wanted to not leak their IP address online and are concerned about privacy? Have they turned it on because they wanted to go and watch a show on Netflix that was only available in a different region, or is this a fraudster that is trying to attack your site or bypass your rules? And so the bigger picture is really important.
So here we are with our second polling question of the day, and of course now I'm worried about my clothing dryer being a res proxy, but it's another story. Let's ask our attendees a question. How do you primarily consume IP data? Real-time API lookups, database flat file downloads, data warehouse integration like Snowflake or BigQuery, third-party tool that includes it, or you don't consume it yet? And while we wait for the attendees to do that, let me go to our audience questions and pull one out for you, Ben. Jin Lee wants to know, how can you know the location in a cloud?
So I think it goes back to like the location can be different things in different circumstances, right? And so if the cloud here is an internet cloud, Google Cloud, right? We know the location of where that IP address is. Where we use behind it can be different through the probe network. If by that he means a cloud or a pool of users, right? In the mobile example, where maybe AT&T that pools users across multiple states. We don't know the precise location, right? Now, what we'll always include in our data is the most likely one given all the data we've observed. What is the most likely location? And so, location can be different things in different circumstances. We don't always know the precise answer, but we always have some data that informs the location we pick.
Okay, thanks for that. Let us go to our results and see what we have. So kind of all across the board on this. Any surprises there, Ben?
I think it's interesting how spread it is, right? Interesting as well that third-party tool that includes it is the winner. One thing we put a lot of effort in at IPinfo is building integrations, right? We want our data to be where our users want to use it, and so we offer data downloads, APIs that mean our users can take our data and use it in any tool they want. But we also try and provide that integration to make it as seamless as possible. So it's great to see that so many people are already using data in third-party tools. Terrific.
Back to you.
Awesome, thank you. So I'm going to switch gears now. I kind of give an overview of who we are at IPinfo, what we do, what our anonymization data is, and how you can use it, and getting deep on that sort of e-commerce use case. I'm going to talk more now about some of the research findings of our sort of anonymization team and some of our research team. And so I think some really interesting findings related to this. One key thing here is that I think is sometimes surprising people just how volatile the internet is in general. A misconception I often hear is, well, yeah, you create this data, Ben, but isn't it relatively static, right? How much does the internet really change? And the answer is it changes a lot, right? And so we see that 16% of all IPv4 IP addresses change city every 30 days, right? And so there's a lot of movement of IP addresses. Mobile proxies, res proxies, we see sort of 5% churn. VPN volatility, 32% of those VPNs change city every month, right? And so these host IPs that the providers can move these around very easily. And res proxies, we see 47 million IP addresses, res proxy, residential IPs in res proxy pools every 90 days. So I think that's a really surprising number for some people, just how sort of widespread this is and how much growth there is. And so the picture I want to paint here is the internet's actually a very there's a lot of movement, a lot of churn in the internet in general, right? And so sort of reinforcing how fresh data is really important, but just how much stuff's going on the internet and how much stuff's moving around all the time, I think is really key. On the VPN research, so we did some really interesting research that I think we're really well positioned to do on for VPN providers. So ExpressVPN, NordVPN, these commercial providers, a lot of them make some claims around how many countries they operate in. And so obviously, everybody's used a commercial VPN. You can go and you can select your country, right? And so I can install NordVPN and say, well, I want to connect through Seattle, I want to connect through India or Singapore, and one of the major use cases for users of these commercial VPNs is the sort of the streaming service regional restriction bypass, right? Whether it's for cheaper prices or to access different content. And so these different VPN providers seem to have gone into this battle between each other of claiming more and more countries, right? And so I think many years ago they'd be like, we're in 50 countries, and then another VPN provider came and said we're in 60 and 70. So it's this sort of arms race of country distribution. And one thing we noticed that a bunch of providers were making these sort of quite outlandish claims about some of the countries they operated in. I think there was one VPN provider that claimed they're in more countries than even exist in the world, something like, we're in 300 plus countries and there just aren't that many countries. We saw a whole bunch of vendors that claimed they're in places where, there was very little infrastructure. In some, I think one provider said that they were in Christmas Island, and you look up Christmas Island and, I think there are hundreds, maybe thousands of residents. Certainly no data centers, certainly no major internet infrastructure. It would be very hard to get a server and route a bunch of commercial VPN traffic through there. And so it just didn't add up. And so we did a whole bunch of research saying, well, let's take all the VPN provider data that we have, right? We know the exit nodes of these vendors, right? That's data that we collect all the time. We know the geolocation data. That's data we collect all the time. How much of these claims actually are true? Is it true that this vendor that claims they have an exit node in Christmas Island actually has one there, and we just didn't realize that there is a secret data center there? Clearly the 300 plus countries claim is wild, but how many of these vendors are being making sort of these exaggerated claims versus how many aren't? And we did a deep dive on 20 of the biggest vendors, and we found that 17 of them made false claims. So there were only 3 vendors where we could find evidence had actual physical servers and exit nodes in all the countries they claimed. And those were, I think Windscribe was one, and they only claimed 50 countries, right? And so when we looked across the data, that was about the actual amount for most of the providers. Most of the providers had sort of 50 to 60 countries where they actually had physical infrastructure, and those countries that, major internet hubs, Germany, UK, America, and a whole bunch of other countries where data centers are plentiful, servers are cheap, they can take a lot of bandwidth. But beyond 60 countries, I don't think we saw any providers with sort of many more than that, right? And so, 17 of the 20 major providers all made claims that we could prove they didn't have servers there. And so that was higher than we expected. We'd seen some kind of wild claims, but we thought that there might be more than 3 of the 20 that were sort of being completely truthful. So that was a really surprising finding, right? And we're going to be doing some more research, doing a new report later this year. We're expanding this to over 50. I think the final number might be closer to 80 providers and providing an update on this. But I think, it's fascinating to see how many of these claims were, completely made up in some cases. And so it's just a snapshot of some of the research we're doing and some of the interesting findings. Res proxies, again, right, we're doing similar investigations here. People may have seen Google did a great write-up. They took down this IPIDEA res proxy pool. And one thing that we've seen that's really interesting is that res proxy, 92.7% of the IPIDEA IPs were shared infrastructure. So these were not residential proxy IPs that were exclusive to IPIDEA. And so it's really interesting that there's a lot of overlap, right? 46% of IPs we see in res proxies are used by 2 or more providers. And so I think it's interesting that there are these sort of res proxy brands, but there's actually a lot of really shared infrastructure under the hood, which was really interesting finding for us. And so we'll run through this example we've got of a life of an IP address, right? This is an IP address in Brunei, res proxy IP. I talked about my office Comcast IP. I think this is just a major ISP in Brunei. And this IP address was part of the IPIDEA pool. And so you can see the activity that we see on it on IPIDEA and related providers. There's a whole bunch of activity. And Google disrupts IPIDEA. And so they did this whole write-up about how they took down this network and the team behind it. And so then this IP address goes dark, right? We don't see any activity on this IP address. I think it's for 10 days, and then it comes back. And so, while IPIDEA and the operators behind that may have been taken down, whether it's a compromised device or, however this IP address is part of a pool, that pool is still very much operational and active. And this is really interesting sort of finding that we see in our data, but this is stuff that we're looking at all the time, right? And seeing what these trends are. So that was a really cool finding. So jump quickly into some different industry playbooks. I think we're running low on time, so I'm going to zoom through these. We've gone deep on the e-commerce one, right? But how do some different people use our data? So fintech and banking is a common use case for us. Different from the e-commerce one, the risk here can be account takeovers, credential stuffing, right? And so similar in that, okay, and events happening, how can we take IPinfo's rich data and come up with some determination of whether this is a legitimate user logging into their banking account or whether the credentials have been stolen and someone's trying to log in and steal their money. IP-related signals are really important there, combined with other signals. So this has been a really key one. iGaming and streaming, right? This is the sort of the regional restriction use case we talked about, right? If you're Netflix, you may not want people from the US tunneling via Mexico to get a cheaper monthly subscription. Or you may have contractual obligations to enforce that certain content isn't shown in certain countries and people are bypassing that. And so it's a really, really common use case there to kind of enforce those. And e-commerce, this is the example we've kind of gone deep on today, right? And this one could be really harmful. I think the Netflix example, there may be very limited impact to Netflix in terms of lost revenue or consequences there. For e-commerce, it can be huge because not only have you're out of the revenue, you're out of the merchandise as well, and so the cost there and payments risk can be absolutely massive, and so the data there can be really, really critical. A whole bunch of trends that we're seeing, right? And so we're seeing growth in res proxy, you've seen more and more fraud, and so all sorts of things happening here and all sorts of things that we're responding to. And then rollout checklist, right? Keep the data fresh, check all the signals. I think we covered a whole bunch of this stuff in the talk already. So where can you get our data, right? Hopefully, I know that a bunch of people in the poll that don't yet have IP intelligence data that are maybe thinking about it. If you've got questions or thoughts, obviously add them in the Q&A. We'll try and get to them, or you can email us and reach out after. But if you're already convinced, you're already like, this sounds great, Ben, I'd love to start playing with this data or have a look at it. We offer our data via database download. You can reach out to our sales team and then give you an overview of how that works. And we can deliver that to you and push it to a bucket. You can download it from us. Data's available, JSON, MongoDB, Parquet, CSV. And then we do full daily refresh on that data. API as well is a really common way. I shared the stat at the start, 3.3 billion, I think now, numbers constantly growing of daily API requests. And here's our API pricing, right? And so our API starts at very reasonable pricing. The max plan is one that includes all the res proxy data, so it's from $78 a month. It can be a great way to get started with our data, to play with it, to see if there's useful signals for you. And then integrations. I think it was 33% of people in the poll said that they use use data within products and services. We've got well over 10 integrations now into various different systems. If we don't have one and you want to use our data in a platform, reach out to us, let us know. We may already have an integration on our roadmap, or we'd love to work on one. We love to make it easy for our customers to access our data where they want it. And so integrations is really key. We also have IPinfo Lite. It's completely free country level data. So there's country level restrictions we talked about. Do you want to block traffic from certain countries? Do you want to go checks? We have a full database download and API, IPinfo Lite, that's completely free. So that could be the easiest way to get started if you're not ready to jump into a paid plan. And then beyond geolocation, I've talked a lot today about geolocation, about anonymity data, and about how the sophistication continues to increase, and you want to write a set of different rules. Going to talk very briefly about two new data sets we're bringing to the market. So one is IPinfo Places. So this is for popular public Wi-Fi hotspots. We will tell you when you look up the IP address, we will no longer just tell you city level location. So here we've got Man City Academy. Historically, our geolocation data will just tell you this is an IP address that's in Manchester. Whereas our places data set will tell you actually what the SSID is, the wireless network name. So it's Man City Wi-Fi here. We'll tell you a category information. So it's a sports center, and we'll give you precise building level coordinates. And so this is for currently a set of about 500,000 IP addresses. So major public Wi-Fi hotspots. We've got the Man City Academy here as an example. Seattle Airport is one that I connect to a lot. So your major public places will get right down to the building level and give you category information. So this currently includes about 30 categories. So hotels, bars, pubs, sports centers, museums, you can see them all here. This is in public beta right now. You can start playing with this as an API for free. If you go to IPinfo/data/places, play with this. We'd love to hear what you're using it for and what you want to do with it. This will be rolling out fully publicly later this year with about 70 categories. And so we're doing a whole bunch of really cool work around this. And so this can be used to eliminate some false positives that you might have on enforcement, right? It may be that you see an IP address that's paying for an e-commerce store. Maybe you think it's risky, but actually it may be someone connecting from a hotel or from an airport. And so you can kind of adjust those rules accordingly. And so that's one great use case there. Another is device count, and this strongly relates to obviously anonymous data. Not only are these the VPN exit nodes IPs that don't correlate with the user location, they also correlate with a lot of users being behind that IP address. And so one data set that again is in public beta right now is device counts. And so if you go to our IP page, IPinfo/ any IP address, we'll tell you our estimate of device counts, and we've got these categories. And so this can again be another really good data set to use for those sort of the same sort of rule-based engine. But yeah, lots of interesting use cases here. But we'll tell you for an IP address, is this likely a single device behind it? Right, I'm here in my office. I might show up as that, or small shared. But then maybe Seattle Airport, right, we would have as a much larger shared one and a different estimate. This is a really cool data set that we are currently in public beta that you can request access to.
And with that, first of all, Ben, I'd like to thank you for that great presentation. If we're not going to have time for all the questions, I'll let you know that we will share them with Ben, who can reply to you offline. So let me get started with a question from Vriyenda, who asks, how do you count devices?
Good question. So lots of work goes into that, right? And so one of our approaches to building our data sets in general is that we are often not product focused at the start. So we think about geolocation or privacy data. The work that our data engineering team is trying to do is to understand the internet and to collect as much insight, intelligence, measurements, observations as possible. And then we use those signals to refine our geolocation, come up with anonymous flags and various different data points. And so one of the data sets that we collect is device data. How many data about devices we see on IP address, and we can aggregate a bunch of this data, right? Some of that is direct signals. Do we have actual data about devices on this IP address? Sometimes it's proxies. So it might be that how many different user agents do we see in website request logs to our IP address that might signify a lot of activity or a lot of devices. And other signals as well. And so then we take a lot of this raw information and we combine those signals in clever, interesting ways that try and give us an estimate on device activity numbers and into these buckets, right? And so it's 1, 10, 100, these logarithmic buckets. What is the estimate of the number of devices seen on these IP addresses? And but it's all based on, this is not just a model that takes a guess, right? This is based on observation and measurement. And so that sort of accuracy is really key.
Okay, thanks for that. Keep the questions coming. As I said, we will share them with Ben. Time for one more. This one is from Charles, who asks, where should a team with no IP intelligence today begin? Where do you get started?
So it depends on, so I think a great place to start is geolocation, right? I think I covered that in the e-commerce one, right? That is sort of the foundational layer of context. It's always going to be interesting to know or useful to know, where is this IP address in the world, right? And that could just be country level. We have the IPinfo Lite data set that's completely free, available to use, and we'll tell you, what country with no accuracy restrictions. That's a full accurate data. And so that's a great way to get started, right? And then it just really depends on your appetite for getting into this world and into this data, right? We offer richer and richer signals. We often have customers that join us with a simpler set of data, and as they sort of see success there, they will want more data, whether that's for investigations. And so, country level data is a really great way to get started.
And with that, thank you to our sponsor, IPInfo, as well as to everyone in the audience. We appreciate your attention and participation in the Q&A and polls. Within the next 24 hours, you'll receive a personalized follow-up email with details and a link to today's presentation on demand. Feel free to share that with your colleagues or peers who may not be able to join us live today. This webinar is copyright 2026 by Informa Tech Target. The presentation materials are owned by or copyrighted by Dark Reading and IPInfo, and the individual speaker is solely responsible for his content and opinions. On behalf of our guests, IPInfo, and the Dark Reading team, I'm Michael Krieger. Thanks for your time. Have the great rest of your day, and we'll see you at the next one.